So, welcome Johan. Thanks for giving this talk.
Thank you. Figuring out all of the wires. So, today I've been asked to give an introduction to Piper and to give a tutorial on this. Though really I sort of changed the subtitle of my presentation so that it's all about the Q, because Piper is built on top of the JTK-Q framework. And I will focus on that today because I think it's a more general interest. So, starting to my research for this presentation, I went back and I found some notes that I made in 2012 when I started doing this work. And I saw sort of I listed a few things that I found on the internet for what were the options at that point. Perhaps there were many, many more that I didn't find, but these were the ones that I saw. And of course, one of my first sort of instincts was that I'm going to do something on my own. I'm going to sort of do the perfect workflow system. It's going to be based on SBatch probably and run on UpMax. I didn't do that, and today I'm sort of lucky I didn't. But BCBio NextGen still out there, I guess, and still quite popular, I think. Bioscons and Pipette, I haven't actually heard anybody mention since then. Maybe somebody else has. And then there was JTK-Q. And at this point, I was just coming out of writing my master thesis. I'd worked on writing a custom JTK walker, so I sort of was kind of familiar with that code, which led me to see like they have something in there that looks pretty nice. And one of the first tasks that I was given as well was to write the pipeline for running this very standard broad best practice analysis and variant calling. And it seemed to have quite a lot of nice support for that as well. So that was sort of the reason for coming in and using this framework. So as I said, this has been developed by the GTK group at the Broad Institute, and they've open sourced it under an MIT license. So this is sort of really where the credit's due. And what's then the difference between Q and Piper? They have a sort of a somewhat different feature sets. So while Q is a sort of general NGS-ish framework for running pipelines, Piper is sort of deploying Q on UpMax, our high-performance cluster here in Uppsala. It has some predefined workflows. So for example, for running exome-seq analyses or RNA-seq and so on, which are not present sort of in the framework itself. And it also has some predefined building blocks for building up these sort of things. However, Q has a lot larger feature set, and sort of when preparing this presentation, I had the feeling, which I think became true as I've listened now before the coffee break, is that most of these workflow systems, they have sort of similar feature sets. They're not, in essence, very different from each other. But the Q, of course, allows you to parallelize your workflow, and it actually has some fairly nice features for doing built-in scatter-gather parallelization, that you can define how to scatter a file, run it across multiple nodes in parallel, and then gather up the results. It's robust, so it can rerun failed jobs. You can specify sort of how many times you want it to rerun until it sort of crashes the entire pipeline. So you can handle sort of intermittent node failures and so on. Of course, as any sort of workflow system, it introduces an element of traceability in what you've done. You can version control it. One kind of neat feature when you're working with these huge data sets is that it allows you to specify files as being intermediate, and these will be deleted as you move along in your workflow. Of course, it allows you to define reusable components, and as I said before, it has excellent support for the GTK suite, since that's where it sort of came out of. And it's relatively easy to add new components, and I will show this in sort of a little introduction to this here, and then in the tutorial you will have the opportunity to try this out yourself. So Q is built in the Scala programming language. I think that this sort of needs less and less of an introduction every time I give this sort of presentation. It has Scala is a language that has had more and more widespread adoption lately. But it's an object-oriented multi-paradigm language, perhaps most known for its functional aspects. It has strong static typing. It's fairly lightweight, at least compared to Java. That's sort of the other alternative. It compiles the Java bytecode and runs on the JVM. That means that you can interact with any sort of Java libraries that are already present. I saw this presentation by one of the guys at the Broad for Q who said like the reason for picking Scala for this kind of project is that it's sort of a scripting friendly language. You get a lot of the benefits of sort of using the Java ecosystem but without having to write this huge amount of boilerplate code that you need to do with Java. So, as this is, I think, one of the most technical crowds I've given this kind of presentation to, I was sort of looking forward to explaining this by code example. I think that's pretty neat. Normally I have to be very sort of high level. So the queue, the heart of the queue is essentially the queue script. This is your pipeline definition, and this is all object oriented. So you have a class, my script in this case, it extends the queue script, and then you must define this function, the script function, and here is where you add your command line functions. And this is sort of the backbone of the entire structure. This has some other nifty features to it, so you can define variables for your pipeline. You annotate these with this type of annotations, inputs, arguments, outputs, and so on. And this sort of auto creates a command line interface for your pipeline. The command line functions themselves, yet another sort of object-oriented feature of this. So you have the command line function class that you extend with your own subclasses. These have parameters. These parameters are annotated as inputs or outputs. And this is actually how Q figures out how to run the jobs. So what it does is that it will create a dependency graph and figure out in which order to run the jobs from there. And then essentially define your command line. This is a very sort of simplish Unix command line here, and that will execute.
I guess it's obvious, but I just wanted to make sure. It's the input defines a type of data, not a type of previous task, right?
Yes, it's a file actually,
Yeah.
and we'll come back to that. So it creates a dependency graph. This is a directed acyclical graph, sort of for the formality of it. This is of course a very simple toy example. In reality, these will span to become very, very large. But you can essentially see you have input files here, some program runs, creates output files, these go on, and it supports multiple inputs and outputs from the program. So you've created your dependency graph, you need to figure out how to run this, so then you have a number of different job runners. So essentially you can deploy this locally in sort of a shell, what we call a shell job runner. It just runs the command lines one after the other. Or you can deploy it with the different specialized job runners. One specialized one for grid engine, LSF as well. I've not used these ones, but I've used this DRMAA one quite extensively. And this should, through these DRMAA APIs, which are supported by a lot of high performance sort of cluster managers, it should have a very sort of wide range of cluster supports through that. That being said, your own cluster might have some sort of local peculiar configurations that you might have to figure out to make this. You kick it off, you get something like this. I've sort of shortened this a bit to fit it into a slide, but you will see, kick it off on a command line, it will give you back your arguments so you can see exactly what you ran, dates and times and so on. Starting to run, and hopefully you end up with something like this, like script completed successfully. And all is fine with that. So, well, what do I like about Q? Well, I like all of these features, which I think are available, whatever, even if I would go with with make, even if I think that has a horrible syntax, I think I would get most of these things. What I do like more about Q is sort of, it's been custom built for running NGS analysis, which means that there are sort of some nifty small like utilities things that you don't have to write yourself, they're already in there. Another thing is that I found it to be sort of quite robust and battle hardened. It's been used for a long time by the Dahlberg Institute to run quite a large number of analyses, so I think that it does have some sort of hard-earned reputation. And I really enjoy the aspect of working with Scala rather than have some sort of specific, domain-specific language to do exactly this thing, because it gives you the access to sort of all of the control structures and so on that you would expect from in full programming language. What don't I like about Q? Of course, I think anything, sort of any point has another side to it. So the file-based aspect of it can be a hassle sometimes. So essentially, as I said, the inputs and outputs can only be files. So suppose you have something that it does not fit easily into that structure, you're not thinking in terms of file, perhaps you want to do a call to a database and do something about that, you will have to drop it into a file and then feed it into the next step. So that can sort of be a bit problematic. One thing that I've really been missing is sort of a modules capability, and what I mean by that is the ability to specify logical components in your workflow consisting of multiple pieces. If I understood correctly, maybe SnakeMake has something like that with the sub-workflow thing. There's nothing like that in Q. Every command line is run separately. Well, this is also a compile language, so you have to wait for compile cycles. And the Scala compiler is still notoriously slow. This can be annoying. And to sort of utilize these parallelisms using, for example, the RMA job runner, you have to have a globally accessible file system and do sort of everything over the network. We've crashed the Max file systems doing this, which was not popular on any side. So this I think is a major drawback, depending on what sort of network file system or shared file system solution. So what about Piper then, which was actually the original title of the presentation? Well, as I said, Piper supports a number of sort of ready-made workflows that we deploy on UpMax and we run at NGI. And these support whole genome sequencing, exome sequencing. We have a haloplex pipeline, and we have some rudimentary RNA-seq stuff in there as well. And this is currently sort of what we're working on, and I think this will be familiar to a lot of people. So we're currently sort of working a lot on extending and optimizing our pipelines for whole genome sequencing and managing that in as efficient way as possible, looking to meet the demands that are placed upon us by these really nice. Into the future, that's what we're doing right now. I hope to be able to submit some patches for the QDRMA support to make that somewhat easier to work with. And also for myself, I think that a lot of people will recognize this. So when you start a project and then you learn a new language at the same time, everything is cool. You think that, okay, I got it working, and then sort of 2 years later you realize that maybe I've done things a bit differently. You want to constantly refactor it. So I really hope this spring to be able to do that. It's of course all open source. Please check it out on GitHub. I'd be happy to answer questions there or by email or wherever, and also submit issues if you want to try it out and you find weird things. That's very appreciated. And with those words said, this is my email address, and below that is my GitHub handle. And any questions?
I'm actually thinking that since there are tutorial sessions, we take all we sort of postpone the questions to that and move along.
I'd like to add one thing. If
Sure,
you're
you
going
can.
to the tutorial, please download the VM. It's rather big. It's about 4 gigs. So we only have 1 hour. So the more people who download it, the more it's better.
Yeah, this was I think everybody who's signed up for Piper has done so, since I emailed about that twice. Why do you laugh? I'm serious. Thanks a lot, Johan. Well, let's welcome our next speaker.